Today we are going to see the scintillation counter, detection and measurement of radioactivity by the different devices is done. Out of that devices, one of the important device is a scintillation counter. One more device is also available to us, and that is the Geiger-Muller counter. Now, in a scintillation counter, we have the a device in which a cylindrical instrument we have, in which interior part of it or interior core of it is seen like this. That main part is called as a photomultiplier tube. This is that photomultiplier tube, and at the left hand side of it there is a thick lead block in which the radioactive substance is kept. Here, see the inside of a lead block sheet. This is the lead block or the outside border of it, and in which at the interior part of it, inside of the wall of lead block, there is a aluminium foil which is a shiny. It reflects the light as well as the alpha and beta particles which are emitted from the radioactive sample source, which is kept inside the lead block cavity. In that, around to the radioactive substance, now we know the radioactive substance like as uranium, thorium, polonium, iridium, radon. These radioactive substances emits the alpha beta radiations, alpha beta particles. That particles are falls on the organic and inorganic phosphor. The organic phosphors are like as xylene, anthracene, and inorganic phosphor like as zinc sulfide, sodium iodide, which are activated by thallium. Sodium iodide is activated by thallium, and the substance. Now, for this experiment, we are going to see or using the zinc sulfide as a phosphor, which is a inorganic phosphor. Now, see the inorganic phosphor is here, which covers the radioactive sample source, which is kept interior part of the lead block. Now, that radioactive substance emits alpha beta particle. It falls on the phosphor zinc sulfide, and zinc sulfide emits the tiny flash of light. See the tiny flash. Tiny means within a fraction of second it emits. That's why the word used as a tiny flash. It called as a scintillation. Therefore, we have the meaning of a this word scintillation means a tiny flash, and hence the counter name is given as a scintillation counter. Scintillation counter having the device shape in a such a way. It's the interior part. The main part is a photomultiplier tube. Inside the photomultiplier tube, There, there are the diodes are fitted alternatively. First diode, second diode, third diode, fourth and fifth, so on. Now, what is the role of diodes? The diode surfaces are covered by the substances like as cesium or antimony and silver oxide. Here is that cesium or antimony. The coating is given there. That coating is responsible to emit the electron. Whenever the alpha beta particles falls on the phosphor like ZnS, it emits the tiny flash. That tiny flash are get collected and entered in this window here. Here is also the little coating of cesium and antimony is here, which emits the single electron. That electron is this first electron. That electron falls on the first diode, which has the voltage is applied 100 volt. See the second diode, it has 200 volt potential is applied, then 300 volt, then 100 volt, then 500 volt. In this way, alternatively voltage is applied in an increasing order: 100, 200, 300, 400, 500, and finally the all electrons which are gathered here in the form of shower. See how the shower of electrons are produced. First electron which falls on the first diode, it emits the 10 electron from the surface of that diode, means from these two metals cesium and antimony or silver oxide, the 10 electrons are emitted out or coming out, which falls on the surface of second diode, which has 200 volt potential is applied. Then that 10 electrons get attracted towards the third diode because the potential is applied here in the increasing order, and that's why 10 electron get multiplies 10 times, means 1000 electrons are emitted from this, sorry, 100 electrons are emitted out from the second diode, which falls on the third diode, and in this way multiplied by 10 means 1000 electrons will create here, which get accelerated or multiply and accelerated and falls on the fourth diode 10 times, and in this way 10,000 electron will creates here, which get attracted towards the fifth diode and finally gets collected on the last diode and the electron counting device. In this device the electrons are collected. Now, to which the electrometers is attached. This electrometer is here and electronic counting device is here, and the electrometer counts the photoelectric current. See, the electrons are nothing but the current. That electrons are counted in the form of the spectrum or the peaks. For example, now see, these are the spectrum which is shown here in a briefly. First peak indicates here the first alpha particle emits from the radioactive sample source and enters in the photomultiplier tube and give the electrons. That electrons are multiplied and finally get counted by the electronic counting device, and it gives a first peak. It indicates that first electron is counted here, which is emitted from the radioactive sample source. In a such a way, second alpha particle enter into the PMT, which is shown in the form of a peak or signal. Second alpha particle, alpha 2, alpha 3, alpha 4. In a such a way, we may count the number of alpha particles emitted from the radioactive sample source. Now, a radioactive sample source not only emits the alpha particle, it may emit the alpha particle, beta particle, that may also get counted by the counter, means scintillation counter. And the same way, we may see the spectrum, and with the help of that spectrum, we may identify which type of particles are emitting from the radioactive sample source, either alpha particle or beta particle. And that's why the title is also here for this device is detection and measurement. Detection and measurement of radiations of radioactive sample source. Now, this interior part of scintillation counter is packed in the box, which is coated in such a way, kept in the box, and that is the metal box. Because these radioactive sample sources are hazardous, they are corrosive, cancerous, or affect the skin, burn the skin, or affect the eyes also. That's why this fully device is packed in a box that kept, in which inside this PMT is kept, and completely this device is automatic. By using the software, we may find out the alpha particles, their number emitting per second or per unit time through the radioactive sample source, or maybe beta particle which are from the sample source per unit time. And these devices are very effectively used in a research or in the pharma industry, in the paint industry, or in the medical field. The advantages of this scintillation counter is it's a simple to operate as compared to the GM counter. See, in the GM counter, the argon gas and ethanol is usually here. 90% argon gas and 10% ethanol vapors are used there. Such thing is not here in scintillation counter, because this PMT, photomultiplier tube, is vacuum. Vacuum is there, evacuated. No any gas or any other organic material is there, organic or inorganic. That's why it's easy to operate. It is highly sensitive to all types of radiation. Just I told here the alpha and beta particles. This device detect and measure. Such thing is not there in the GM counter, and that's why this is a suitable for the counting the radiations, means scintillation counter. Now this device scintillation counter differentiate the protons and hence used in the gamma rays spectrometer. Differentiative protons. See, the protons are having the in a different functional groups: aldehyde, ketone, ether, ester, amine, amide, acid, like substances, or the protons in the aromatic compounds or in the aliphatic compounds in a benzene ring or in a different types of bigger molecules also, that different types of protons this may identify, or this device can identify it. One more advantage of scintillation counter is it has short resolving power and therefore more efficient for counting gamma rays. Short resolving power. Gamma rays may also counted by this device and therefore more efficient for counting gamma rays. Resolving power. See the number of alpha particles, beta particles. These are the having particle nature, but the gamma rays are the rays which is having a continuous emission of light energy that may also identify with the help of this device, and this is the most efficient or significant application of the scintillation counter. These scintillation counters are now in the form of sophisticated devices available in the market of different companies made in India or in a foreign countries like as Japan, Germany, UK, which are recently using in the many more research centers where there is the applications of power generation for medical field or in a pharma industry or in an industry like fertilizer, paint, or chemical industries. Very efficient and very good devices are available of different companies having the basic concept of scintillation, means a tiny flash. This tiny flash is very energetic and gives such a type of a peaks or counted the alpha beta particles. Friends, in a research laboratory, after the your master degree or at the time of research like as PhD, or if you have any project of radiology or radiochemistry, then you may use this device properly Thank you very much for your patience and for your attention.